Okay, kind of a weird angle a little bit here, but we're going to try this. This is the third part of explaining how to do a motion diagram. I have copied the data to a piece of paper from the previous two Jing videos that show how to get the velocity versus position information, and I'm now going to make that into a diagram. Now, taking a look at this data, the largest value I have for x and y is 0.4941 meters, and the largest value for y is 1.708 meters per second. What I'm going to do is I'm going to scale this in order to make it fit on my board. Now, this would be a little bit small, 0.4941 meters, so I'm actually going to make the scale times 2. So that means that that number would become 0.9882 meters. So the x-coordinate for my first one is going to be 0.9882 meters. And what I'm with the y-coordinate, with the velocity, is I'm going to actually take it and scale it down by 10 and make this into 0.1708 meters, because I'm making an arrow to represent the velocity. So let's try that out. I'm going to put in that meter-long scale to start out with. Here it is. Okay? And we have here the start, and the start, of course, is at 0 meters. And then where the 20 is, that's actually now going to be the 10. Where the 40 is going to be the 20. Where the 60 is going to be the 30. Where the 80 is going to be the 40, and this is going to the 50. So let's put those things in. So this is really 0 meters, 0.2 meters, 0.2 meters, 0.3, 0.4. The mark or spots, our initial spot, of course, was 0, 0. So we're just going to put a dot in here and say, okay, that's our initial data point. The object is starting from rest and not moving. Now let's put in our second data point, or 144. 0.0144 meters, multiply that by 2, so I'm going to locate it at 0.0288 meters, or 2.88 centimeters, and I'm going to represent that by an arrow, which is that divided by 10, 2.78 centimeters long. So let's do that at location 2.88 centimeters. We're going to make an arrow, so go to 2.88 centimeters, which is about there. Put a little dot there, boop, and then put an arrow in, which is 2.8 centimeters long. And there's our first arrow. Okay, now we have our first arrow in. There we go. Data point effectively here. That's at the speed we have here is 0.648 meters per second. We're going to represent that by an arrow, which is 1/10 that long, 0.0648 meters, which is 6.48 centimeters. So put that in. Let's take a look. Here we're going to, there it goes, that point about there. And it's going to be 6.5 centimeters long, which is going to be about this long. Okay, and that's the next data point. Now, we've got 3 more here. We've got 0.165 meters at the next data point times 2. That means that's 0.33 0.12 meters. And the velocity coordinate at that point is 0.998 meters per second, which we're going to represent as 0.0998 meters long. So almost 10 centimeters. Let's put that in. We're at 0.3312 meters. Let's mark that on here. 1 centimeters. And then about 10 centimeters long on that arrow. There we go. All right, so with that arrow, here we go. And we only have 2 more. I'm going to rush a little bit here to get those in. So 0.3085, that would be 0.6, so that's 61.7 centimeters. So that's where that dot goes, about there. And that's about 13.7 centimeters long. There's that. Okay? And the last data point is at 49.41 meters times 2, that's 98.8. Put that in, and that ends up being 98.8. It's going to be somewhere over here. Boop. And the length of that arrow should be 1.708 meters. Convert that, that would be 17.1 centimeters. Put that in here, and that's our last arrow. So, where does this leave us? This was the diagram for the force sensor plus 100 grams. And just for reference purposes, I feel like one of those cooks, I've prepared the diagram for force sensor plus 20 grams. Now, take a look at the difference here in those diagrams, and you'll be fascinated. Well, I'm not sure what's fascinated, but you'll notice what's happening here. The diagram with force sensor plus 20 grams, the arrows are closer together and they're not as long. Okay? That means that the cart is not moving as far for each time segment, and then is not moving as fast at the end of that time segment. The force sensor plus 100 grams is moving in such a way as to have the dots closer together and further apart, and each time it moves, it accelerates more, it speeds up more, so its speed is larger. Okay? So that's that, and this should bring, hopefully, the segment on motion diagrams to a close. Now, of course, you're going to make these drawings on paper, but otherwise the same principles apply here. You have to scale to a degree that fits onto your graph paper.